All right, I wanted to do a Meet the Scientist interview series here. It's August the 10th at around 5 p.m. I want to introduce you to two of our Crested Butte-based employees. Both work exclusively on the SFA. They're both Rumble employees. On the right, we have Amanda Henderson, and on the left, we have Chelsea Wilmer. What they're going to walk us through here today are the flux measurements that are being made at the Pumphouse Lower Montane experimental study site. I think most people are pretty familiar with this location, but I really wanted to give folks an opportunity to see how these flux measurements for both carbon fluxes and water fluxes are being made when we're comparing our control and our early snowmelt manipulation plots. So Amanda, why don't we start with you? Why don't you go ahead and start describing to us exactly what you and Chelsea have been working on so far?
Yeah, absolutely. So we're incredibly interested in the effect of snow on these meadow ecosystems and how they are functioning. With an earlier snowmelt, there's a lot of different outcomes that could be possible, but one of the ones that we expect is most likely is that there'll be an extended drought period that these plants experience between the time of snowmelt and abundant water and when any sort of summer precipitation hits.
What's the precipitation been like this summer? Pretty normal? I mean, you've been out here for many, many years, or been a weak monsoon? It
was a weak monsoon. Billy's records, which go back 45 years, have it at about half average.
Half average, okay. So in a location like this, Chelsea, I mean, these plants that you're seeing are under pretty severe drought stress at this point, yes?
I would say that the spring was wet enough.
Yeah.
And it was late enough snowmelt that the control, like that plot over there, might not be feeling as bad as maybe this plot. And up the gradients, I would say that they're actually doing okay, given that there has been a weak monsoon.
Interesting. But, so in this sense, this above average, well above average snowpack coupled with the late melt and the wet spring may have actually buffered these plant communities to some degree relative to what a quote-unquote average year would be. Well, actually, why don't you go walk us through exactly what we're looking at here with the measurement device for these flux measurements. How about you first describe the tent?
Yeah.
Not exciting, but critical.
Super high-tech piece of equipment that we have here. It is made out of a fabric that lets in 70% of photosynthetically active radiation and has a canvas skirt so that we can place this over any area of meadow and basically create a closed atmosphere. We use a chain to seal it in place so that we can actually see the signal of the plants and not just diffusion of air in and out.
Looks like we're going to be focusing on a very specific plant here. Is that the case? Can you identify it for us non-plant people?
This is Artemisia tridentata, and it is otherwise known as big sagebrush.
Big sagebrush. Is there a small sagebrush?
Yeah,
not here. Okay. So big sagebrush, and you've got your measurement device here, and it looks like some fans blowing. So tell me a bit about that sensor and why we're using those fans.
Yeah, this is an infrared gas analyzer made by Lycor. It's called the Lycor 7500. It's what's typically equipped on any EdiFlux tower. And we kind of have a unique method of using it, which is just on a tripod that we can move around and place anywhere that we want.
Right down in the sagebrush in this case.
Right down in the middle of a sagebrush, trying not to chop it up too much. And the fans are there to circulate the air so that the sensor doesn't just have like stagnant areas of air because of the tent closing it up.
Fantastic. Well, speaking of the tent, why don't you go ahead and box up this sagebrush for us. Show us how a measurement would be made.
We tried to do it very carefully.
Looking good. For those of you in the know, we've got Pete Raymond inspecting the signal coming in.
I'm good on this side.
448, 450.
You seeing some change over there in the measurements, Pete?
464.
Well, there's the chain.
So this is water that we're looking at here. So our water is going up.
Okay.
And the carbon is going down. It's photosynthesizing.
Fantastic. Just what we were hoping to see.
Yep.
So Chelsea, real quick as we wind this up, can you give us sort of a general sense of any crude differences or gross differences that you're seeing, not just here, but the other locations where you've been measuring, between the manipulated plots where we've intentionally melted snow early and the control plots? Any differences you can see just at first pass?
Well, I think the difference is most stark at the beginning of the season when the field melts out fully. You can see just a stark difference in how much plant material has already grown in a early melted plot compared to a control plot.
How about with the onset of the rains? Even though it's a weak monsoon, have you seen much difference in terms of the behavior between manipulated and control plots tied to monsoons?
I haven't seen anything really. That's it's a fine scale difference that usually happens. But I assume that overall the early plots probably experienced a sort of monsoon rescue event where they were on the downswing. I think we saw that, the start of droughtiness before the monsoon just because of a longer drought. And then a bit of a bump up in production and movement of water with the monsoon, whereas the control plots never got quite as droughty, and so maybe not as much of an impact of the monsoon.
Fantastic. Well, obviously there's going to be a tremendous amount of data to process going forward, but thank you both for that introduction and that demonstration, for all the hard work this season. Thanks again.
Thanks, Ken.